Glad to have you. This video is going to be aimed toward unit analysis and unit conversion. Okay, so where I want to begin is talking about conversion factors. Okay, so that's where we'll start, and then from there I have 4 planned problems that I have written out. We're going to answer those problems, so let's go. So first off, let's talk about a conversion factor. Okay, so if someone asks you how many inches are in a foot, you would simply say 12, right? So there are 12 inches in 1 foot. Okay, so those two measurements are exactly the same. They're just using different units. 12 inches is equal to 1 foot. So we can create something called a conversion factor from inches to feet by saying 12 inches over 1 foot. Okay? Or we could flip that fraction and say 1 foot over 12 inches. So no matter which of those two fractions you're looking at, both of them reduce down to 1, right? Because they are the same length. That's called a conversion factor. And conversion factors are really important in case you want to take one unit and convert it to another. All right, so let's start with this problem. The problem says, how much will a person pay for 8.6 pounds of bananas at $1.37 per pound? Sounds like a lot of bananas, okay? I love bananas, but goodness gracious, that is quite a bit. So what we want to do here is read through the problem and figure out, is there a conversion factor that we're given? And we are right here. If it will, right here. So one thing you do have to remember is per stands for division when it comes to mathematics. So think about miles per hour. Miles per hour is miles divided by the number of hours that you've traveled, right? If you want to know your average speed over a certain trip, you take the miles that you drove and divide it by the number of hours that you have been on the trip, all right? Or if you want to look at your speed at a particular moment in time, you look at your speedometer, and that tells you 55 miles per hour. If you were to drive at that constant speed, 55 miles per hour, in exactly 1 hour, you will have traveled 55 miles, right? So per means to divide. So this $1.37 per pound tells me that I have a conversion factor. I have $1.37 per 1 pound of bananas. Now I'll just put 1 pound. Let me thicken my line up a little bit. Or 1 pound over $1.37. No matter how I look at this, those two conversion factors simplify down to 1. All right. Now I need to figure out which of these two fractions will I use within my problem. Well, let's read again. It says, how much will a person pay for 8.6 pounds of bananas? So our end goal is the unit of money. So if I want my unit of money to be my end goal, I need that to be in my numerator. All right, I need that to be in my numerator. There needs to be no other units within my answer, just money. So if I need that in my numerator, well, which of these two fractions will I use? I'm going to use this one. Okay, so now that I know I'm going to use that fraction or that conversion factor, I'm going to say $1.37 per 1 pound of bananas. And then how many pounds were we trying to buy? 8.6. 8.6 pounds. And we can just write that as a fraction by writing it over 1. Okay? And what's cool about this is whenever you multiply fractions, remember, if you have the same number at the top and the bottom of a fraction, that reduces. If you have the same factor in the numerator and denominator of a fraction, they reduce. Same thing with units. If you have the same unit in the top and the bottom of a fraction, they reduce. So my pound unit is now wiped out. It's no longer there. And so now I take multiplying fractions, you take the top, multiply it by the top. So 1.37 times 8.6 is 11.782. And then 1 times 1 is 1. Okay, and so what unit of measure do we have? Well, we have dollars. So we would just round this to $11.78. All right, so the second example is we want to be able to convert 2 years to hours. So how many hours are in 2 years, right? Think about that. It's going to be a pretty large number. This problem is going to go through a few conversions in order to get to the actual answer that we're looking for. And I do have one little note up there. I want to disregard leap years. So how many days are in a year? If it's not a leap year, there's 365 days. If it is a leap year, it's 366. So we are disregarding the leap years. Only consider a year as being 365 days for this particular problem. So I want to take 2 years, and we're going to convert that into hours. So 2 years, let's just represent that as a fraction. Okay, and the goal here is I want to start with the year unit but end with the hour unit. So being that my year unit is in my numerator, I need to have a conversion factor between years and some other unit of time, and my year unit needs to be in my denominator so that my year unit cancels. So let's just say 1 year. Well, what comes to mind when you think of 1 year? What other unit of measure? 365 days. So in my numerator, I'm going to have 365 days. Okay? So I can go ahead, if I want, I can go ahead and cancel out my year unit. Now, well, if you multiply 2 times 365, that will be the number of days in 2 years. But remember, we're trying to get to how many hours are in 2 years. So now we need to say, okay, well, I need to cancel out my day unit. So 1 day. Okay, so 1 day is 24 hours. So in my numerator, I'm going to write 24 hours, right? And therefore, my day unit cancels out. And so what do I have left in terms of units? Just hours. That's exactly where I want it to end. And so now, in order to find the answer, what I want to do is take 2, 365, and 24 and multiply them all together. So what do we get? We get 17,520 hours. All right, so let's go to number 3. This problem is going to be much more fun. It says an air conditioning system can circulate 300 cubic feet of air per minute. There's that word per again. Remember, that means division. How many cubic yards of air can it circulate per minute? Now, this one's a little bit tricky because we're talking about volume. Let's read what we have. Well, we have an air conditioning system that's circulating 300 cubic feet of air per minute. Well, let's write that out as a conversion factor. 300 cubic feet, so feet cubed per, remember, means to divide, minute. All right. And so now we have to be very, very careful because it says how many cubic yards of air can it circulate per minute. So I'm going to keep my minute unit in my denominator because it's asking for cubic yards per minute. So I need my division to be divided by minute. I need to convert my cubic feet into cubic yards. And this is a little tricky because we all know there are 3 feet in 1 yard, but we're talking about cubic feet. All right, so how many cubic feet are in 1 cubic yard? Well, we're going to use the fact that we know there's 3 feet in 1 yard, but these need to be cubed. So you do have to be very, very careful here. In order to cancel out that feet cubed unit here, I need feet cubed in my denominator of my conversion factor. So notice what I did there. In order to make that feet cubed, I need to also cube that 3. Okay, so my conversion factor is actually going to be 1 cubic yard, right? Because 1 cubed is 1 over 3 cubed is 3 times 3 times 3. So 3 times 3 is 9 times another 3 is 27. So that is the conversion factor that I will be using, not this. And now we can answer this problem. My feet cube units will cancel out. I have 300 cubic yards over 27 times 1 minute. So 27 minutes. Now we'll actually go to our calculator. 300 divided by 27. So this is about approximately 11.11 cubic yards per minute. And there we go. Now, whenever you're doing these problems, make sure you read carefully with how the problem may ask you to round. In this problem, I'm assuming it's going to ask me to round 2 decimal places. So this problem kind of talks about comparing unit price. Here's the situation. You can buy shampoo in a 6-ounce bottle for $3.99 or in a 14-ounce bottle for $11.69. So which is the better buy? So let's call this option A, and we'll call this option B. Okay, so what we want to do is find out how much each ounce is. So what is the price per ounce? Well, option A, $3.99 per 6 ounces versus option B, which is $11.69 per 14 ounces. All right, so we'll go to our calculator and we'll say, well, $3.99 divided by 6 is about 60, is 0.665. We'll round that to money to the nearest cent. So it's about 67 cents per ounce. All right, and then option B is $11.69 divided by 14, which is about, it says 0.835, so we'd round that to the nearest cent, 84 cents. Now we have a proper way to compare these instead of just looking at option A, which is $3.99 versus option B, which is $11.69. We can properly see that option A is actually the better buy because you're spending less per ounce. And that's what we want to use to compare unit price. We want to make sure everything's in the same units, money per ounce or money per liter or whatever the case may be, they have to be on level playing fields so that you can properly compare their unit price. All right. So I hope this video helped. I have plans for many videos to come. I hope you enjoy this video. Be safe and come back to the classroom.